Top Gear is finally canceled.
I did, yeah.
Super good this time.
There's okay, so I love Top Gear. I loved the original Top Gear.
Yeah, same.
The one I watch a lot now is Throttle House.
Oh, okay. I don't actually watch that. Should check
I think
that out.
that's the closest replacement to Top Gear out there.
Yeah, I feel like that show was really the presenters. Like they tried to like recreate it so many different times in so many different ways with so many different people, and it's like it was just the chemistry between the presenters that really made that show.
Yeah, and that's where Throttle House comes in, because there's two guys. One's kind of British. It's not kind of British.
How do you be kind of British?
Yeah, I don't know. I guess I'm kind of American. I don't like to claim it all the time. So, but and they have that chemistry, you know, and it's very like, yeah, they're very fun, energetic, super knowledgeable. I would argue they're way more knowledgeable about cars than most on-air celebrities like that. So yeah, check out Throttle House. And if Throttle House is watching this stream, whatever you guys want to do with like the extra cars, I know they probably go back to the dealership, but I would gladly take like a 911 GT3, a Audi RS6 Avant, just to name a few off the top of my head.
Yeah, I'd take either one of those too. Distribute them evenly across the presenters of this show. That would be great.
There we go. We can trade. Speaking of, Jesse, you weren't you just out with seeing a customer that did cool car stuff?
Yeah, actually, and I was actually just thinking about that because related to Top Gear, I was just watching a video this morning with Richard Hammond, and he drives the new Rimac. Have you seen that? The Rimac that he flipped off of the mountain and crashed. He went back and drove a new one, which was kind of cool. But obviously, like hypercar, that's all electric and wild. And because of that, I was just thinking we were in E-Muscle Car, went down in Dallas. It's super cool. They're taking like existing cars, mostly like vintage muscle cars, and retrofitting them with electric, all sorts of electric stuff.
Cool.
Super fun. Yeah. We got to ride in the Cobra when they do, it's kind of a combination. They like kind of started off with the partner of the company bought a car from one of the auctions and was kind of like driving it around, and it broke down, and they were like, this isn't for me. Like vintage muscle cars isn't for me. I just kind of want something that's like ready to go all the time. Like I can just hop in, it's going to be reliable, and it just needs to do what it's going to do. So they kind of started off on this quest of like taking a vintage muscle car, which, requires some, wrenching and attention, and say, okay, can we get like that same form factor, but have it to like totally just hop in it and go at any point in time. So they ended up going the electric route with it. Okay. And super cool. They're doing some awesome stuff. They definitely talked me into it while I was there. At first I was like, I don't know about the idea. Yeah, but so they do like cars that they pick up, and obviously it's not like, rare spec cars. It's stuff that needs a motor or whatever that they can clean up and retrofit into something that is pretty sweet at the end. But they also do that with the super performance Cobras. So that we got a chance to ride in the Cobra when we were there, and that thing moves. It was a ton of fun.
That's awesome. I thought it'd be cool. I love that idea, right? It was moving into EV, and the one I want to do is get an early 60s Volkswagen Bug.
Oh yeah.
Or even I think a Carmen Ghia would be really cool.
That'd be cool.
Either one, Cal style, lowered a little bit, and then run an all electric version. And just have it be insanely fast.
Yeah,
I'm sure.
Yeah, I mean, that's the thing with electric. Like they just move so much to you.
There you go.
Yeah, that is the face of an electric Cobra.
As a face of a car enthusiast enjoying instant torque.
Yeah, instant torque. And when we rode in it, they had it set up for autocross the previous week or something. So it was already like pretty cambered out and pretty stiff in the back. So it didn't even like hook up that well, but man, that thing was fun.
Okay. Nice, man.
Was super fun.
Did you watch the Tesla Cybertruck unveiling, or watch the event at all?
No, I saw some bits and pieces of it online, but I didn't actually see the event. I saw they were racing it against a Porsche GT3 or something. I don't know if that happened or not. But...
Oh no, it was. I think it was just I don't know if it was a GT3. It didn't look like it, but it was a 911 and a Cybertruck drag. And then the Cybertruck eventually pulls forward to expose that it had a trailer with the same Porsche on it.
Okay. I feel like they pulled that stunt with the Model X or something too.
Yeah, it's very Tesla marketing, but
yeah. You can't deny the torque on those things is crazy.
No.
But
Not at
anyway,
all.
well, looks like we're about on the hour, so I guess we can get started with the episode. Thanks everybody for joining us today. I am super excited about this episode. This is going to be a ton of fun. We're talking complex models. We're talking bikes. We're talking to Mike Sandy. It's Friday afternoon. What more do you want? Thanks for jumping on with us, Mike.
Yeah, thanks for having me.
Absolutely.
Excited to be here.
Totally fun. So you've got a couple examples. So obviously we were talking a little bit as we were just jumping on and talking a little bit about design intent,
Mhm.
sitting down, like almost that prep phase before you start modeling can be so super important, but especially when you're getting into complex things. And that kind of the direction that you want to go today.
Yeah, yeah. It's funny because I thought it'd be fun to do something surfacing related and filling out we have a little card, a little survey sheet, like, hey, what's your objective here? And I put design intent in there, but not as a primary topic, although that's what it kind of rolled into be. So I think it's a great topic to discuss. And I've got a couple really basic examples to explain my interpretation. And I think probably all have a similar interpretation of what design intent means, and then we'll get into like an actual bike, because to me that's like a holy grail, and I'm not the master at it by any means. The bike manufacturers out there using CAD every day, God, they can do this stuff. But we'll show some examples of like modifying a frame dimension and having your model hopefully not explode. And whether that happens today or not, I don't know. We'll see.
So yeah,
It'll be a good discussion.
especially with surfacing, right? I think, and maybe this is how you ended up going down this path, but I think surfacing, people are initially scared of surfacing because it sounds so much different than what you're normally doing. It was always one of my favorite topics to teach about, though, because it's like eh, I always kind of liken to like it lets you speak the language of SolidWorks, right? But with that complexity or that ability to get into the nitty gritties, it does. You have to be a little more intentional. And maybe that's how you got to where you're going today. But having a good plan coming in, I think, is extra important when you get into complex stuff like this. Frame that looks
Totally. And I think one thing I was thinking about is, have you ever designed something, maybe something that's a little bit more complex than you're used to, and then you decide to start over, and that second attempt you do is always like exponentially more intelligent. Like,
yeah.
does that ring a
Yeah,
bell?
probably every model I make, I get to the end and I'm like, "Man, I should have done that differently." But I
Right.
mean, hindsight's 20/20, right? So a lot of times, especially if you're designing something yourself, like you don't necessarily know where you're going to go, and SOLIDWORKS is very good about adjusting. And it's like, "Okay, I should have started this in a totally different manner."
Yeah, totally. So that we'll do that today. And this is what I've got up here is a frame. I did this, man, I don't even know, years and years ago. We can look at the feature properties, 2017. So this is an old model. It's when I had a lot more time to spend in CAD. And this is actually, we were just talking about it, ordering things and watching videos. I had bought a new bike frame to build. And while I was waiting for my frame to come to be excited about it, I decided to design that frame. The problem is, in this is not specific to the bike industry, but we'll kind of talk about the challenge there is when a bike is designed, they design around a lot of constraints. Specifically, actually, I'll pull up an example of a spec here. You have the fit of a bike, and the fit of a bike is what like makes or breaks a different type of bike. So a road bike versus a downhill mountain bike versus a BMX bike, obviously they all look different. But
Mhm.
even if you look in mountain bikes, for instance, which is what I do a lot of mountain biking, is they all have tweaks to their geometry. So let me grab some reference images. There we go. So meaning like a cross country race bike is going to have a couple angles different on just how the fork is
Mhm.
positioned, and that like 2, 3, 4 degrees difference there, they call that slack, and that's going to modify how the bike rides. So what you'll see in this industry is they'll take a bike frame, they'll design it for cross country racing, but then they'll want to have an option for people who are more into like leisure trail riding or do more downhill, and they'll add slack to it, a little more travel in the suspension. So they need to have a model that's super intelligent that can abide by these changes. So just kind of look at like what the geometry is, and I'll open this up. is they spec these things, and when you buy a bike and you're kind of comparing them, you'll spend a lot of time just looking at what these properties are. So like the slack angle, right? You
Mm,
have that. You've got these are just some of the basic specs. Let's see, I can't really move around. Yeah, so reach, stack, seat tube, head angle, seat angle, head tube, chainstay, wheelbase, standover. Like all of these dimensions are critical dimensions
wow.
when designing a bike. Yeah, it's pretty complicated.
So is that mostly just for like riding? I actually don't know that much about frame design, but I've always been kind of curious about it. Is that just like for riding dynamic, like with the motorcycle and stuff? It's the same kind of idea, right? You've got different rake ankles and things like that that kind of define what the bike is for. I would assume that's pretty much exactly the same here.
Yeah, so again, like a cross country bike's going to have less slack in the front head tube, which is going to be kind of this angle here.
Okay.
And the reason is as I'm racing, I want the most efficiency I can get, and I get to a hill to climb. If I have a really steep front or shallow front angle, so it's more extended out, I'm going to be pedaling into my suspension. Even if you can lock it out, you still have a little bit of give, so
Okay.
you're
Yeah.
losing energy as you do that. So they'll modify that angle. The distance between where the crank position is, where you pedal, to where you're seated, that's going to change. Like a beach goer or a cruiser bike, those where the crank is way out front because you're sitting back, and
Yeah.
it works different muscles. Generally, people riding those don't have the physique as a XC World Cup racer, right?
Yeah.
They're not as strong in the hamstrings as they are in
I
the
do, of
quads. So
course. I do.
bike designers, oh, you of course you do. Yeah, so they're all designed around like, all right, who's the rider? What's the intention? How do we get the most comfortable ride or the most efficient ride out of
Okay.
the geometry tweaks? So again, when they're designing these, you need to have those all in mind, which comes into the design intent. So going back to this one, I'll show you an example of like what most of us, I'm pretty sure every SolidWorks user has run across is like, hey, I created this really cool bike. And what I did here, we'll just take a look at the sketch, is this is kind of the master sketch. This drives everything. And that was my goal. Is here's the 650 wheel. You can see the wheelbase. These are all pulled from the manufacturer's, right online. You can get these dimensions. I've got this style spline. We'll talk about this in a little bit. But what I wanted to do is say, let's tweak. Let's see if we can even just pull this out. Okay. So we'll pull this spline out a little bit, right? Maybe that's the modification. And obviously when we exit, we want it to update. Great. That actually worked. Maybe not as manufacturable. I don't know. We could dive in and talk more about that.
Mhm.
And the example I wanted to give is actually to break this thing. So let's make a little bit bigger change. Like this would be something changing the seat tube. So we change that seat tube angle to be a little bit steeper. And there we go. That's the area we're probably all familiar with. And quite the list too. All right. Yeah. A lot of fillets. Fillets are usually easy to repair. Split lines. This was cosmetic. But it's not the frame that I was looking for.
Right. Yeah.
So going back to it, it's like, all right, my intention was to create a large size frame and then modify the dimensions so I could create an extra small, a medium, a large, an extra large. And on top of that, make tweaks, right? If we're going to prototype this thing, go ride it and say, that head angle is too steep. We don't want to have to start from the beginning in CAD. Does that all make sense?
Yeah, definitely. And I think
Right.
it's one of those things that I like to talk about too, where like if you think about things ahead of time, like we just said, every model I go through, I get to the end and I realize I should have done things differently or could have done things differently to make my life easier. But there are definitely things, even when you're not sure where you're going, there are definitely things that you can think about ahead of time that
Mhm.
will drive how you set things up, or will allow you to set things up in a way that will make more sense for you. And I always every class I always taught, I would encourage people to do that. Just think ahead and see if there is something that will make your life easier, because there probably is in any scenario. And it's worth taking that 10-30 seconds ahead of sitting down and just digging in. It will probably save you hours if you just think
Oh,
about, like,
totally.
what is it that I'm actually trying to do here.
Yeah, and I, it's hard to kind of predict changes, but when you're in industry and you're starting to work more and more through a company, and you'll get a better feel for what changes might occur.
Yep.
The bike frame example is like, hey, we need more slack on the front fork, so change that head tube. So yeah, you'll kind of be able to better understand what to expect, but that's not always the case.
Yeah.
So I think to your point, just really sitting down, you have a design project ahead of you, write them out. Like, what are the risks that you can your model might entail as this is going? What kind of design changes do you want to design for to build intelligence? And start with a basic model, even like a scrap model. So like, all right, if I build this and this and this and this changes, does it blow up? And you can kind of use that as a baseline.
Yep. Yeah, I will do that too. Sometimes just kind of rough things out and say, okay, that's
Yeah.
about how that's going to work, and then start the real model.
And as much as we want to like jump in and dive into a design right away, like, yeah, just having, because you're inevitably most likely going to be repeating it if it's not perfect.
Yep.
Because you can always make it better. So start with something that you're willing to scrap, and then come in and ready for that production kind of design. So I think on the topic of live design, I've got a real basic model brought up, but on the topic of design intent on live design, there are a lot of tools built in the CAD, into SolidWorks, that are naturally there for users to build this into it, like patterns. Perfect example. Circular patterns, linear patterns, component-driven component patterns, all of those are there to help you as a designer speed up that process and also predict changes, right? A pattern, if we want to go from 8 to 6. One that I used to show, this was like 2015, I think 2016 is when it happened, was the old ladder, right? So we come in here, someone has a ladder, and there might be a change, or most likely we're going to have different products that come out with different ladder numbers. And you'll see that I've got some design intent already built in. This bottom rung is 12 inches from the base. We don't need to have it any smaller. We could probably go a little bit higher. Depends on who you talk to, but 12 inches is a pretty good spot for that. So like I was mentioning, we can go into features and we'll create that linear pattern. And this they brought in, it was like 2016 maybe, where we can do up to a reference. Otherwise, this used to be something you'd have to create a bunch of global dimensions, name them, do some math inside of here. And this is really cool. This is an easy way to include some design intent. So I'm going to create that vertex. I'm going to give this maybe an offset. So we also want that 12 inches from the other end. We'll space these at 12 inches. And then here, don't need features for newer users out there. If you're working in a multi-body environment, patterns need to be selected for bodies if you're doing bodies, and it'll create the same pattern as we'd expect. But what's cool is it has some intelligence built in. So this is greater than 12, but that means that there's not enough room for this to actually be 12. So if I come back, let me just extend this out, and there's a request for a really long ladder, we can pull. And we see the design intent here is like, hey, I want a master model that can create any length of ladder. So super easy thing to model. I know we're going to get into much more complex, but I think that illustrates a great way to build in design intent into your designs.
Yeah, and I think design intent itself can be a little bit vague. Sometimes it's hard to explain what that means to somebody, because it can really impact any part of your model, right? It can be in your sketching or a part of a feature like you just showed, but it's really a mindset more than anything, right? It's just like, where can I take advantage of the tools that the software has to make it what I want, make it do what I want it to do, right?
Yeah, totally. Another area too is just using equations. So here what I've set up is that this thickness here is just set to 0.2, and this is probably now that I look at it as a bad example, but you can drive equations. So if I double click here, we see all I do is enter the equal symbol. You can click or manually select the nomenclature. If you're new to these, it's kind of worth learning. It's just the order D1. So for the first dimension on whatever sketch. This was the 6th sketch. I must have done a couple more. So a fresh new part, sketch 1, sketch 2, sketch 3 as you create them. And it just keeps numbering. So that's all it is. It's just the first dimension that I added at the 6th sketch I created. So again, I guess I created a couple more for the basic extrude, but and so you can equal those, and you'll notice that I just have a multiplier of 10. And again, this is just for an example here. So if we go to 0.3, you'll see that's going to drive this length. And it also drives these other dimensions, right? So again, some design intent around here, just into a single sketch. And another cool one here is like linking to global variables in sheet metal. Whenever you create a sheet metal part, thickness automatically is defined. So notice this radius here. This is at 0.13, 0.125. Looking at the lower right there. If I actually come back into my base flange, we'll edit this feature and we'll override these. We'll go to like a 1/2 inch or a 1/4 inch, whatever. 0.25. Let's see. I can type today. And click the OK. That goes. And then you'll see now we have, hey, that didn't update. Might be because I overrid it. That link to thickness can modify it too. So, again, just ways to be aware, like, all right, why or what might change down the road. Have a plan. Really.
And I like those couple examples too, because I think sometimes people have a tendency to, and myself included, when you're working through these things, to say like, I don't have time for this, I'll just punch in a number. But like those couple of examples there are, they're literally like point and click. Like it barely takes any more time to set up that equation or link to a global variable than it might be faster even than typing in a value. So it's not like something that's got to like really drag down your workflow to try to work all that smarts into it. It's almost comparable in time sometimes.
Yeah, totally. Spot on. All right. Let's see. Anything come from the chat? I see
We've got Eric making fun of me for my 10-30 seconds, which he reduced to 5/16, which is a funny joke. I meant 10 to 30 seconds. It was a range of time, Eric. Thank you very much.
Hi, Eric. Good to see you, as always.
I like that.
I saw Joy is on the call as well. I always get nervous when Joy's on the call because she's an expert in all things. It's like, got to watch my words. That's why we love Joy. Cool. So yeah, thanks for joining as we go along. If you guys have questions, or even more so, there's a lot of experts in the chat. Share your experiences. I'm by no means, I don't work in this industry. I work in the CAD industry. I don't work in the bike industry. I've spent a lot of time with bike manufacturers, helping them out and learning from them. But yeah, share your experiences in my points, because it's super important that we take that opportunity. All right. Should we try to design a bike frame?
Let's do it.
Okay, so disclaimer, I was going to redo the old frame that I've already done once, because, right, when you do a model again, it's always better and more robust. And then I decided, but it'd be more fun to do a bike that I want. And then I started doing this. I'm like, this is a little bit more complicated. So I actually have not gone through this other than to where I'm at today. So we'll be doing this together. I make no promises. This may not go well, but hey, that's live design, right? This is the life we live.
To be honest though, like that's the best way to learn things, right? Just find a model something that you see that you like, all right, how do we build it? Let's give it a try. And then, like you said, next time around, it goes even better.
100%. And if you're wanting to learn surfacing and you're a car guru like Jesse, you are, and I am, that's how I learned. I was like, I'm going to model a car, and it's going to be a long, painful process. And it wasn't that bad. It wasn't that bad.
Yep.
And then I went to a bike, and bikes are probably a little easier, but there's actually a bike model in the surfacing training manual. So if you're interested in learning more, reach out to your reseller and see about that training class, because it's great.
It's a great one. Honestly, I think that was my favorite class to teach, because like I said earlier in the episode, surfacing is one of those things that like people get nervous about, but I always tell people, just open up the surfacing tab and look at it. You'll recognize more of the tools than you won't recognize, right? Like that first bank of tools are all the same thing. You're just working on faces instead of, full features or whatever. And I always like the analogy of like, you're speaking the language of SolidWorks. When you're doing surfacing, you're just doing what it's normally automating for you. It's like writing a sentence with words, and then surfacing would be like using the alphabet to spell. You have a finer. You and I are terrible spellers, so maybe that is not a good not a good analogy, but it breaks down somewhere. But
so true. Yeah, it's left to right, just like everything else. Most commonly used things to the least commonly used things in the command manager, which I think, to me, once I realized that's how SolidWorks is set up, I'm like, all right, cool. So I always start on the left side if it's new to me. And those are probably the tools I need to figure out the first. So all I did in here, I created a sketch picture. It's just insert sketch, use it's tools, sketch picture, and then get that to size. And even though this is from the manufacturer's website, in production environments, this would come from ID, right? This is going to be a hand sketch. that the industrial design department comes in and they're going to slap over. Engineering is going to have some baseline dimensions to start to work from, whether it's an existing frame, whether it's feedback from a mule, which is going to be just their prototype version out there, pro riders. They'll kind of have a start. So I'm not cheating here by having this image. It would be generally from an idea if it's a completely net new product line or part number. Once I have this in here, and again, it's been scaled to size, this is really where, when we talk about setting up the model and being smart with it, is spending a lot of time on that master sketch. So what I've basically done is used somewhat of a center line. It's not a true center line. You're going to have kind of like this here is really based on some of the geometry conditions. Like there's a kind of a hard edge on this particular frame.
Yep.
And I want to make sure I'm meeting that when I start creating the surface geometry. I actually spent a lot of time looking at the geometry and trying to figure out how I'm going to go about this. Where do I want to start? Simple. I always start simple areas. And then where do I want to kind of have at the end of my tree, which is the more complicated sections. And that's a lot of where the frame is meeting up with other parts. So for this front triangle really consists of a couple key things. Down here, this is the bottom bracket. This is the bearing housing where your crank goes through. All your power is transmitted. That's super important. And that's where I put right at the origin. Everything around the bike design is going to be based on that. The other thing you'll notice is that I have a line here to accommodate the position and angle of the headset. This is where your handlebars go. Again, that design there is critical. It's depending how much reach is going to be, how high it is, how much slack is in the geometry. And at 67 degrees, this particular bike, it's pretty standard these days for a cross-country bike. Even like 10 years ago, this would be almost vertical. They're like 88 degrees, super steep. Wow. So you've seen this change in design over the years. And side note, this is because World Cup mountain biking racing is becoming more aggressive. They're putting in drops, they're putting in huge boulder fields. And to accommodate that, the bikes are having more slack because they can ride over that. And it's a fine line, right? You don't want to have too much vertical and you're going to go over the handlebars.
Yeah.
But you get more efficiency on climb. Too much way far forward, you have this massive long wheelbase, like a downhill bike, and they can just cruise over boulder fields, no problem. But all of a sudden, you're going to be fighting against your suspension.
That's actually pretty interesting because I always wondered, like, I mean, you're much more into the bike world than I am, but I always kind of wondered, it seemed like every year there's some like new trend or, the wheels are always getting bigger and whatever. But I always kind of wondered what's actually driving that? Like, is it just like technology changes and they figure out a better way to do something? But you're suggesting here, it's actually a little bit of just the sport itself, like the terrain that they're typically riding, it drives a little bit of that too.
Depends whose checkbook you're talking to, because a lot of people believe the bike industry makes the changes to drive demand. And I think there's relevance to that. But in terms of like a bike frame geometry, the changes they get come for good reason. So today's modern XC bike is a really fun bike to ride. It's still really fast.
Yeah.
You go back 10 years and they're scary. It's like driving a Formula One car if you're used to a Honda Prius or a Toyota Prius. Honda Prius. That's a big jump. You're most likely gonna die.
Yeah.
Not to be that extreme, but so in here, you start to lay these out, and really what I'm looking at are like, what are dimensions that I'm going to modify and change. And you'll notice this thing is fully defined. I do want to make sure it's fully defined, but fully defined doesn't always mean just slapping a dimension on everything until it's black. And I think a great example is if we start to play, and I'm going to look at my plan, is like, what if the positioning of the rear suspension, maybe there's a modification where we say, hey, we're going to go to 140 millimeters of travel versus this 100 or 160 versus the 140. This is 120, whatever it is. They want to extend that suspension up. Can I adjust that without having any problems? Mm-hmm. And here we see like, okay, that probably would be bad because all of a sudden we're moving where the head tube position actually is. And that's we want that to be set to this 443 dimension. So it's moving it down. So not ideal. So that's like, all right, cool. Let's kill a dimension that's maybe driving that and redimension this angle accordingly. So I'll do that. Here's a nice little, grab my dimension tool, and I can actually set an angle selecting on the line and then the vertex, and you get this little triad that pops up.
Love that.
And I'm going to set that here. Okay. So 30.7 for whatever. I'm not worried about those values right now. So then come back and test it. Like, does this give you better behavior? It's looking better. It's still got some movement, but it's not as dramatic, right? So it's kind of just spending a lot of time in 2D. A lot of time in 2D, especially if it's a master sketch that's driving the intelligence.
Yeah, that's a really good illustration of what you were talking about earlier, because this isn't even like get to a dummy model. This is just playing around with a sketch to see what is going to happen, which obviously with a model that's this complex is really helpful to know, especially when you're combining that with instant 2D, in this case, just kind of sliding things around like, okay, what is actually going to happen here?
I mean, it's like, it's the coolest thing to think about the power of 2D. When you have advanced geometry, basic geometry, mathematical geometry, you could sit there all day and figure out, okay, so this angle is here and that means this and this. But what's really hard is to say, what happens when I change this angle? Yeah. And this one's not allowed to change. How does that affect it? And that's where CAD can do that, because you have the brains of the CAD system behind it. So take advantage of it. And I can think of a lot of other scenarios in real world where I'm like, I'm just going to create a 2D sketch and I never even get to 3D. Yeah. Like just to figure that out, like look at using DraftSight for those types of things as well. But SolidWorks does a phenomenal job. Yep. So you spend a good chunk of time here. Like really what happens, the likelihood of a seat tube change. All right. This is probably one that I got to work on as well, because that whole thing is shifting. Mm-hmm. And so I probably will come back and refine and look at the dimensions.
I like your concept of like, if it's black, it's fully defined. Yes, it is, but it may not be defined the way that you want it to be. Like just putting 100%. A dimension on it doesn't mean it's going to do what you want it to do. I like that concept.
Yeah, it's super important. So spend a good time here right up front on that 2D model, move stuff around. If it doesn't look good, make the change. So I'm going to leave it as here just because we're stuck on time, and keep moving forward. But you can see right away, like I'm setting myself up to probably not be successful if my goal is to be able to refine these things. Yep. Maybe in this model, like, hey, if we put a little more seat tube angle to it, that's fine to tilt it up. Maybe there are some allowances there. Those will really come down to, again, your design intent. Another thing, Jesse, I do too, that I use a lot is being able to color sketches. This is kind of just an easy thing to stay organized, but setting up sketch color, you can just right click on the sketch itself, goes into here. And I just, something bright, I did for live design, but I do this personally to give that contrast. It looks really nice.
I do that quite a bit myself. I like that.
Good tip. All right, so we have kind of this master sketch, and again, I'm going to try to leverage and always focus on the master sketch when I create features. Now, what I did in this model, that's a little additional, is I've created the master, and then I've gone through and I've started to create this profile sketch. And what you can see here is really this is going to be helping me determine where and how thick some of these tube components are from the profile. Mm-hmm. Some of these are definitely like we know the values. The seat tube diameter is the outer diameter is 34 millimeters at 31.8 millimeters ID. So I set those, and here's an equation, right? Both sides are equal. Great. But just kind of giving me a reference based on that. A lot of these other ones, 19.98. So this is kind of a true center line. I've just got those tied. You could also just mirror that over, but for the sake of just creating this kind of outline, and you'll see where that comes into play. On the top one here, I only created the top profile. It's not fully defined. Not a big deal. I'm using this as purely reference, and I'm going to do, if I use it for anything, I'll make sure that I go back and fully define this accordingly. So yeah, this is just something I've added to this workflow, is like, all right, well, I'm creating some sketches. I might as well build it out. So when we look at it without the image, and let's just do, I'll show those in a sec. We'll hide out the reference plane. Let's show the profile sketch. And here we can start to see, all right, here's the geometry. This is what we're going for. It looks pretty good.
Yeah, and that's a great point too. Like it's okay to pencil things in sometimes, right? Like if you're not sure about exactly what it's going to do, you can pencil things in. Just go back and lock it down if you're going to use it. At some point, define it. Make sure you're defining the things that need to be defined. But it's okay to be a little bit fluid as you go through a process.
And if you're doing something that's just kind of there for a visual reference, the thing too is like use those sketch colors and say like, hey, don't use this at all. Like if you're going to end up using this for something, we need to make sure there's more intelligence. So you can kind of flag it with those colors, which is, I don't know, to me, a nice visual cue.
That's a great point.
All right, so we kind of have the layout done to it. Again, probably not going to get me to my desired result. I'm going to go back and I want to finish this model and make it super intelligent. Just not going to happen in the next, what do we got, half hour. So then once we get this section here, it really comes into setting up where we're going to create the cross sections of each element. There's a few spots that are super simple, creating the revolve around where the headset's going to go, creating the diameter where the seat tube's going to go. And also the other one is going to be the bore of where the bottom bracket go. The reason that these are simple, this is industry standard, kind of. Most mountain bikes are going to have a pretty much set bearing size and type of headset. There's a bunch of, historically speaking, there's been a bunch that have come out. Road bikes, mountain bikes, all have different ones. But for the most part, when speccing this, we know what kind of headset we're going to get. C-tube, 31.8, 30.6. There's like two basic C-tube diameters. I think everyone is at that 31.8 or whatever. And bottom bracket, same things. So I kind of start there and start to create some of that profile. We'll start to create those sketches. But here's the next spot I actually want to hit into is the reference planes. And in order to start defining out, the easy spots we mentioned, the seat tube, the head tube, we'll add those in a sec. But I also want to have the start and end profiles for each tubing element. And we're going to start here. We're going to also create one here. We'll create one here. And once we have the three main forms of the triangle, plus the spot, the headset, then we'll come back and refine the joints, because this is where like 80% of the work really comes into play.
Yeah. Real quick, Mike, before you jump into planes, we got a comment from John that says you can use your F8 key to easily access your colors in the tree. Is that true? I didn't know that one. Do you select on the sketch and then hit F8? How the heck does that work?
Sketch F8. No, I've got a function override, I think. Yeah. Not on mine. I'm working with 3D Experience SolidWorks, so there may be a difference there, but
different. I didn't know that one either. We'll have to play with that.
Yeah, cool. Thanks for the tip. I'm writing that one down. So we jumping over to like the next big chunk of this is just setting up reference planes. And I've already created a bunch of these. So let me just go through and kind of show you the process. Because I remember when Tim Newton, my old boss and coworker, who was like a SolidWorks genius, showed me this one and it blew my mind. And most of you probably know this. I was young and didn't know much at the time. But when you create reference geometry, I want to always have these basically based on that master sketch. And you'll notice I've actually added in a couple little nodes like here. And let me go back and just show you a little bit better.
And you did that with just split entities, or what did you do that with?
I did, yeah. Okay. You could sketch it. In fact, this one could be moved a little more. And where I want this to be is essentially where we're going to have a little more complexity in it. Yeah, so if you sketch something out, instead of adding a line or resizing it, you can always come into the sketch tools. I get it from the right click menu. And inside of here, you have somewhere
right at the bottom there,
split entities. There we go. So split entities, and you can just take and pop that in. Yep. So that one's really nice. And I'll show you another one with the style splines as well as we get there. So I've added that in here. And the reason I have that in there is that's going to give me where I want to create some reference planes. And what I can do is select on my line, select on my point, and right away that creates a perfect normal to plane on that line.
Yes.
And what's great about this is then as we go through and we modify that master sketch, that plane is always going to stay right there, normal to. And it's also nice is that when we go through and look at this plane, and we'll go ahead and create a sketch on it, is that little coordinate system that's popped in there. That is nicely parked right where it's defined. So I know where that relation, that 0, 0 point for that sketch, I should call it, is going to be based on that master sketch. That's
a great tip, because that's one that you would not maybe suspect that you could do unless somebody told you that you could do that. But that is a really easy way to control, especially the normal direction of a plane. Right?
I did learn this is going back. The size of the plane created has some sort of equation based on the dimension. So this one's a lot smaller.
The length of the line in this case.
Yeah, which I thought was interesting. And then you can go through, and once you set up your planes, you can go through and here it is, flip normal. You can flip the normal around on these ones. That's basically the default that it considers normal when it goes to the view and how it's sketching. So
whoever knows that was added, put it in the chat. I don't remember.
2019. That'd be my guess.
I don't know. That's my guess.
All right.
Somebody drop it in the chat. Correct us.
Flip normal. When was that added? All right. So yeah, go through, set them up. Oh, you can size these too. So like, obviously this is probably everyone knows, but sizing the plane so it's not a complete disaster. And then naming. I name everything. I try to name everything.
Good habit.
So getting these named, kind of give it like, what is the down tube top, down tube bottom? That is what it is. This is the top of the down tube. This is the bottom of the down tube, seat tube as well. And then you have these name references. They're easy to follow. If you're not naming things, well, you're crazy.
That's going to be the clip for this episode. If you're not naming things, you're crazy. We got some clarification on F8. It's the display pane. That's why that popped out when you.
Gotcha.
You can
display pane.
Quick access.
Okay, so it is working in my version.
It is working properly.
All right, thank you.
That makes sense. That is good to know, actually.
All right, so I've got a bunch of that's kind of organizational things. Again, just going back, spend more time than you think on that master sketch, that initial sketch, if it's going to be the intelligence, right? And oftentimes that stacks up over time. To me, I think I often just jump in and create a sketch, fully dimension it, and move on without really questioning why and how. Totally. People who work in industry for a long time obviously know this. They practice it, they understand it. So for newer designers, like the 2D sketch you create has a lot of implications. Make sure you understand them. And if you don't, go ask someone who might, or figure out, write it down. Like, what are the risks that this model might have? And then from there, in this particular design, I start creating those reference planes to be able to build it. And then I love display states. So I'll start to come through and create out a bunch of display states that allow me to hide and show. And what I do, I actually never go to the configurations tab for this, is good trick. This little chevron, if you right click on it, this is where you can access your display states on the fly. So like a show all, brings everything in. My seat tube hides out that sketch, gives me the master and just the plane I need for it. So super handy to me.
Yeah, display states that are not linked to configurations.
Yes, yeah. So you can link display. I'm not using configurations yet. We essentially would, but and these are nice for design reviews as well, using display states. So if you're hiding a bunch of stuff, you've got different appearances you want to apply to things to point out during a design review, you can create a bunch of those. Like customer comes in, they want to see their products. Just going through display states to kind of show that is a nice way to do a presentation as well.
Yeah, that's definitely probably an underutilized tool in SolidWorks.
I don't know what else people use display states for. Showing a cheese appearance versus
yep, probably.
I don't know why I thought of that. Guess I'm hungry.
Wisconsin's coming through.
All right, let's add some geometry. So like I said, we're going to start easy, and this is all going to be surfaced. We'll start surfacing, and eventually we'll get to some solids. But and if you're new to surfacing, and if you don't see it, right click and go to your tabs, and you can see all of the cool tools that are available. These are all, doesn't matter what version of SolidWorks you get. You're going to have feature sketch, you're going to have surfaces, sheet metal, structure systems, and so on. all inside of here. Lifecycle and collaboration, I'm working in the new version, the connected version of SolidWorks, so I'll have that as well. So I'm working on that right now. Save to the cloud and revision and manage all my content there, which is super nice because I work on multiple computers. I can hand it off. All right, so yeah, I'll turn on.
Thing on that. I love how easy it is to pop those on and off. Like I will do that on a project by project basis. I'll just swap my command manager around to just have the tools that I need there. And I know you can like use the scroll wheel and whatever to get across tabs and all of that, but it's just so nice to just like narrow it down to just the tools you're using. Even in the phase of a model, I'll switch those up just because it's so easy to do.
When I was doing a lot more CAD work, I had reg keys for kind of everything. I had a reg key for weldments. I had a reg key for, well, surfacing was the big one. Simulation were the two that I would switch to. And then I had my kind of default. But yeah, load your surfacing reg key, which would change a lot of my mouse gestures over, change my S key. Simulation, like pre-processing, prepping for simulation was a lot different. So I would load that reg key.
That's trickier than I got, but I like your style, Sandy.
I don't know. I think it was effective. It was more like, check this out. Look what I got.
You never did anything all day long. You're just calling people over to your desk, swapping reg files.
I have 37 new reg system settings now. You never know what I'm going to do. Right. Okay, so going in, create an extrude, just like you would normally with basic features. An extrude surface is just like an extruded, but it's just the outside shell, right? And it's infinitely thin. Now we can later convert those to a thicker model. And again, so design intent. One area that I think when you learn in essentials is there's different ways to create different end conditions whenever you create some 3D geometry. So in this case, like up to vertex, and you don't have to select it from the drop down. It's smart, right? If I click on a point, it understands that vertex. I don't know, maybe not. Blind up to vertex. Maybe that one. Point there, master point 20 at master sketch. And the goal here is that, hey, if that C2, we say we don't need that set area. This is just like basically we know the max C2 depth of this bike has to be here, so we can set it there. And then now it's driven back to that master sketch. So we'll go and click it. We'll say this is actually going to be up to there. Good deal. Exit, and it's updated.
Yep. Another thing that's easier to do than doing blind and punching in a number, right? But if you think to do it, it's going to save you a lot of effort.
So that's one simple one. Headset, another one. The headset geometry here, this morning, I decided to add a little extension to it. And this was when I was playing with the failed version, the failed bike, is I noticed as I was going through, a lot of the fillets would extend past the headset. So what I thought is, hey, why don't I have it be larger than what I need? I can go back and modify some things and figure out what the max headset height stack should be. And I'll cut that later. So go big and I'll refine it down the road versus saying, I know exactly what it is.
Learned from the first model.
Yep. So pretty quick. All right. Pretty simple. We got the easy part. Thanks for tuning in to Live Design. You guys have a great weekend. Now the hard stuff, right? Okay, so let's go down to the top tube. And the top tube has definitely got a little bit more. In fact, there's actually 3 elements here. And we'll take a look at this reference sketch. Because I want to get your opinion, Jesse. How would you do this? Oh, actually, let's get the audience's opinion. How would you do this thing here?
That lets me off the hook. I like the audience opinion better. You guys can give me ideas in the chat here. Get me out of a bind.
I'm waiting for someone to email me a completed model of this. Like,
yeah, they're already finished in the time.
While you were jabbering on about C-tubes, I actually did it for.
I guess they're probably 30 seconds behind us. But so I try to break things down into like where are the consistent profiles. But in this case, the top profile that basically runs from where you put that split kind of down to where it sort of Y's off. Yeah. So I think I would be tempted to do that whole section straight down and then trim out part of the bottom to do where it flares for the shock. That's my initial thought, because
So
that profile across the top basically runs continuous, right? So I think I would continue that all the way and then just trim out the piece that I needed to blend in for that shock mount.
Yeah, I like that. That's actually not where I started. My original thought was to create this here, the whole top tube as one kind of swept surface, I guess lofted, because we're going to have two different profiles, and then deal with it later.
Yep.
I was like, I'll deal with it later. And then good old internet. I'll show you this because I'm working between two bookmarks here. I could probably. I did find this. This is good old off their website, and I love when companies use CAD screenshots for marketing content. It makes me feel so validated for some reason. So this is a lot. Like this, basically, I saw this and I was like, "Holy cow! I can probably feel better about myself because I see they do have a lot of tangent edges, which is great. These bikes are beautiful, by the way. If you ever get a chance to see an Orbea, they're a Spanish company. I don't know what they use for design, but so yeah, I found this little cheater, and this is when I realized, because I don't have one here to design from. If anyone wants to buy me one, I can send you the specs. So yeah, I agree. I was like, well, this here whole top shell, this whole top piece should be my first chunk. So that's what we're gonna do. And then we'll deal with the rest.
Later. You're a CAD guy when you're finding pictures on the internet and spying on their tangent edges to try to figure out what they're doing.
How do you guys do this? Okay, so here's a good example of where the outer profile sketch I created is going to become super valuable. So I probably need to go back and take my master sketch, take this profile sketch, and make sure that these work well together. So again, play with the 2D, move stuff around. Does it behave like you'd expect? If so, move on. But until then, so I'm going to leverage the profile sketch, and I'm going to probably do it the wrong way, but we'll talk about that as I get there. Okay, so I'm in this top tube geometry, and we're going to create a spline. Splines have been evolved over SolidWorks over the years. For those of you that use like the basic spline tool, I don't even know why we still have it. I think I wish I could just delete it.
I still like it, to be honest with you.
Do you? I never.
Yeah, for quick and dirty stuff. For anything that's like actual geometry, I'll go style spline every time. But for when I'm like tracing something that's an image or something, I like using regular spline.
Yeah, I guess that's true.
Freeformy stuff.
Yeah, a little bit easier.
Yeah.
So what I've got here is I'm actually going to attach this point. I'm going to pierce it to that sketch. Well, I'm going to create another. I'm going to do a converted entities from this, which probably isn't needed. I could just go back and modify this one, but for some reason I have that stuck in my head.
And a pierce being like a 3D coincident.
Yes. Yeah. So yeah, if there's no end node, I can't create a coincident node, but a pierce is like threading fishing string through a hook. And
good way to describe it.
Great. Yeah. So piercing that, just threading it through my endpoint. The reason I like style spline so much is you can fully define them. It gives you these control arms, which allow me to provide some dimension to. And I also love having these initial and end control arms. These, you can set it horizontal. Let me go back because I'll show you another cool trick. Another thing that they brought in. And that's going to let me know in most cases that we're going to have, when I mirror this over, I'm only going to do half the bike because it's way faster. It's half the weight, right?
Yep.
I'll mirror this all over so we have perfect symmetry. So doing that, you want to make sure that there's no ridge here. This is carbon composite. They can build most things. There's not a lot of design constraints. There definitely are, but not like aluminum tubing where I can just make stuff up and say, go hydroform it.
So that's actually, I was just going to ask about that because there was a comment about like thinking for manufacturing, and I was going to ask, I'm assuming this is carbon.
Yeah, definitely. They've in the world of bikes, the big thing you've seen recently, it's a lot harder to go look at a bunch of new bikes and say carbon versus aluminum. 20 years ago, super easy, constant, stock tubing, butt it up with some welds, probably not carbon. But what they're doing now is they're hydroforming a lot of these tubes, into mold. So they fill it with water. I don't know if they heat it up or what, but I think a lot of it's cold forged, and they just use hydropressure to build aluminum tubing. Aluminum is still very prevalent. Titanium, steel is still very prevalent in the bike industry. Carbon. The nice thing with carbon is it allows designers to stiffen and soften areas of the bike where they need it to be. If you need compliance, like underneath the seat for a nicer ride on a road bike, carbon, you can do that. You can't necessarily do it as well with,
That's
So
interesting. Like with like the thickness of the carbon, they build in some gib, or how does that work?
Yeah, so the weave, the way that they actually do the layup, the thickness of the layup, and then the geometry cross section too. So like if you look at road bikes, you may have a super thin chainstay, which is the one that goes to the back wheel, the bottom one. But those are generally really rigid, like twisting rigidity is high. They're generally thicker because you want it to flex because that's your ride. You take some little bumps out of there. But yeah, as you're pedaling and that bike is torquing over. So yeah, areas of power transmission, they'll make stiff. Areas where they want flex, they can make soft and give you a better ride because you don't want
something new every day.
Mm-hmm. Yeah, so that's why carbon's, I mean, you can make an aluminum bike super light. You can make a carbon bike lighter, but you can make it the variability of like flex and stiffness is easier to work with.
That's pretty cool.
All right. Any bikers in the audience? I didn't even ask. If you're a biker,
how do we miss that?
That could be e-bike, that could be Harley rider, that could be whatever. If you ride something with two wheels or even one.
I was going to say, what about a one wheel or something? Is that count? Unicycle? Unicycle.
Yeah, our local trail, they have unicycles that ride a 2.8-inch big fat, like 26-inch wheel.
That's
they ride
awesome.
mountain bike trails. It's crazy. I yield to those guys there.
Yeah. They're crazy.
Yeah. So coming back here, so I would kind of get off topic, but it's live design. It's meant to be fun. Is I'm going to kill that dimension. So one thing that's cool, about this out is I want to create a horizontal relation. And if you didn't know, when you create these relations, they added this box, this little highlight box to tell you what it's closest to. So like if you're cockeyed or you have a weird coordinate system inside of there, just you can rely on that to at least give you a good start. So if I was sideways and I thought it was vertical and you click vertical and everything blows up, it was actually horizontal. Just look at that outline. So we'll create the horizontal relationship there. We'll do a vertical one here, although we don't need it. I don't think that flare could be greater than vertical, but and then obviously just start to shape this a little bit. So style splines, whenever you're working in splines, something to be aware of is, let me go back. So I added 1, 2, 3, but this one might be not needed. You can add and remove these little control points. So if I right click on here and go into, and I might need help here, Jesse, because my 4K monitor doesn't let me see. Sketch tools. Nope, it's in spline tools.
Yeah.
You can add and remove spline points. You have to right click on the spline. There we go. Right click on the spline. Yeah, that's what it is. So the control arms won't do it. So if you right click on the spline itself, this is where you can take and insert controls, and you can also delete controls. So if there's something that you don't need, come back. Nope, not delete the whole thing. Remove the controls. The other one inside of here that's really nice to know is this curvature combs. So I enable that. Mm-hmm. And curvature combs are basically please correct me if I'm wrong here, but the rate of curvature of your model.
Yeah, that's how I think of them.
So how fast it's curving, really important when we talk about C1, C2, C3 curvatures. Another reason I like style splines, it's going to get you into that C2 area where we have nice continuous combs, and I can see that visually.
And I feel like probably this is a little bit less helpful maybe with a style spline, because you're looking at the actual cage of it, so you can kind of visually see where things are going. But with a regular spline, it's really easy to get the curvature to invert, where you push one handle a little bit too far, and then you've got a dip in there, and that is a great way to see those really, really quickly. With the style spline, definitely has the advantage because you're looking at the cage, so that helps out visually too.
If you start playing with style splines and Jesse comes knocking on your door and says, dude, why aren't you using regular splines? I use them all the time. You can convert as well.
Yeah. Great point. Right. In general rule, I always just say I do less points than I need, and then I add them in because I just feel like that's easier. It's the same kind of the thing I like about style splines too is once you get a handle on those, that kind of helps your mindset when you switch over to other surfacing styles like X shape or something like that. It's very much the same idea of like working with that cage, and then it's sort of interpolating that spline in between. Same idea, like start with less loops and then just add in loops as you go. Splines, less points, add them as you go.
I think just in general, start with everything cat. Start simple.
Start with less.
Yeah, I always do the opposite, and it burns me, and I start over, and then I fix it. And then I go, start simple, Mike. And then the week later, I do the same thing.
Todd says, despite all my rage, I'm still just a spline in a cage. That's
good.
That's pretty good.
Hey, 2024 feature. I don't know if anyone's out there right now, but one of my favorites is this preview dimension. This came from our X Design app. Yeah. And what I discovered the other night is that you can turn it on and off right from the in context toolbar. So here, this preview sketch dimension, if it's disabled and I click on it, nothing happens. With it on, that just lets me click on the value and it's defined. So, and it's smart too. Like if I do a control select on 2, you see the angles brought in. Pretty cool. Pull that out. And it'll just add. And a couple of these, again, I just like talked forever about the importance of not just defining to define, but we're going to do it anyways.
Do as I say.
I actually want this one.
Somebody just said, was it Joy? I lost the comment now, but somebody said a 2-point spline is overlooked. And I agree. I use 2 points all the time.
I 100% agree. All right, so we are just adding some dimensions. This is just for the profile, which is going to be refined, and most likely in real world. So again, as we talked about the importance of profiles, that creates different rigidities. This is like a really good where you would see handoff to an analyst group, especially in composites.
Yep.
You get them in the frame, they come back and they say, hey, torsionally, this thing just isn't there in the top tube. You can start to refine these. And that's where why bikes now have more like crazy geometry to them. It's not all aesthetics. It's also, it goes back to that stiff to weight ratio type thing.
That makes sense.
Okay. So we're pretty close. We've got this, but I'm going to leave this dangling because again, as you mentioned, Jesse, we're going to try to accommodate this as one piece and we'll cut it out. How are we doing on time? I feel like
we're getting pretty close.
Yeah. All right. I'll try to hustle here and just at least get some geometry besides this YouTube. So create another sketch. So on that, see, like here's a great example. I have no idea where I am, but I know that's where that line intersects. So that's a nice way. So one thing when I do style splines is I kind of go 1, 2, 3. I used 3 before, so let's use 3 again. But this one here is going to be about there. And we can't have that go past. Let's see if I can mention in the plane. Do it to right plane. We can't go past the seat tube. -3 millimeters. That's not what I wanted. How'd that bump? Which is 31 millimeters. Let's just say 15 at 30. So we're good there. And then we'll just add in some constraints. Okay. And we'll create that pierce. Looks good. And not fully defined, but for the sake of time, we'll start to come through and look at this. Because I want to just do one last thing, a couple last things. We got some time. Thanks for hanging with us, guys. Let's just go through. I'm going to create a converted entities, argue all day. Do I need to add another reference? Probably not, but in my head, I keep doing this, so I'll probably learn that the other way. Curious to see what you guys would think. Would you just go back, convert the initial sketch after we said I wouldn't be using it? Because remember, I was going to color it red as a reminder to not use it, but now I'm using it. See, this is totally live design.
Yeah,
this is like what happens.
Making decisions on the fly. The chat is getting out of hand too. I've been now nominated to.
Are they all telling me I'm doing it wrong? Because I
no,
like
no, they're
okay. I was like, all morning I was like, everyone is going to tell me I don't know what I'm doing, and I'm okay with that. I am 100% okay with that. All right. I wish Ben Lofton was here. So we're going to create a surface loft. I think more than anywhere in SolidWorks is where I use the selection manager.
Yes. I agree.
isn't surfacing, right? So selection manager, get to know it. It's your friend. It's pretty easy to figure out, but this is where you can say, we want, let's go back because I don't know. We could actually just steal this. Do a lofted surface. Oops, telling me that. I don't want that. I want my guide curve, selection manager. See, and then as I start to like hustle, there we go. So grab all three, right? Yep. Let me go back because I want to just point this out. Selection manager
would probably do
here. Yeah, you're probably right. And you'll notice my mouse has the right check mark. So newer users out there, be aware of when that comes up. This could save some clicks. When I right click it, it just okays it. I don't have to go up to the check mark and it adds that group. Yep. And then let's create the loft. That looks good. Can't see, it's on the other side. And then we'll just do, look at that. Seat tube. Nope, I didn't have a top tube. I thought I had a top tube. Oh, well.
If you don't name your stuff, you're crazy.
Nice.
Immediately comes back to bite them.
Nice. All right. So, Jesse, I think at this point, we're good. But the problem is we don't have enough overlap on that. So no big deal. I'm going to come back. And that's why we leave this open. And I haven't defined that. And we can stretch it way down because we're going to trim that later. And hey, that looks pretty good.
There you go.
Pretty good. Right plane will come in here. Let's go ahead and turn on that reference plane. And then maybe I'll use style splines or regular splines. Just kidding. I would never do that. No, I didn't. I used style splines because I'm not crazy. And then
name your stuff, and if you use regular splines, you're crazy.
All right, now I'm just kind of Russian, but just to show you, and not Russian like
the nationality.
I'm actually Finnish primarily, if you've wondered.
I did.
Yeah. So this stylistic, and again, this would be kind of iteration back and forth with probably an analysis group to see what we're doing. But and guys, I do plan to finish this, and I'll probably create a series of shorts around it, or at least rolling through the process and post those to the SolidWorks channel. So if you're in, yeah, I'll try for sure. That'll give me something to do next week, right? So we'll tune in for that. It might not be for a little while, but basically what I want to do here is just kind of walk through how I had finished this up. So we're going to do a trim. We'll trim this out. Trim surface. You can use a sketch. You can use other surfaces. And then it's just going to remove out what I want. And then let's just do not that button. Oh yeah, I forgot it. I did not see. Okay. Oh, I'm all over the place. How about we just hide it all like that? Okay. So my plan of attack here would be, I missed this part, is to create this section of it, and then I would do another lower portion up to here. This would be one section of tubing. Another one would come through probably into here. I wouldn't merge those. I would thicken both sides of that and then merge it, because we have this weird cutout down here. So there's a lot of complexity I would need to come through. And I think I could get away with just doing two solid bodies and then merging those. Yeah. The down tube, this is pretty easy. And then where the where the time is going to be spent is in all of this complexity. So sorry to not get into the really crazy stuff. But I hopefully, and I have more because I want to show something that I've also been playing with. But really, this is kind of, my design intent is to be able to have some intelligence. If we go back to the master sketch and we start to, this is probably going to blow up, start to tweak, this angle here a little bit. Maybe we extend out this geometry. And I'm using, if you guys are aware, Instant 2D. This is on. If you ever get it where you're like trying to, oh no, I don't want that to come up. It's most likely because you have that on or off. Like now I click on this and it doesn't give me the option to select the value. I have to double click to get to this. Does that make sense? So sometimes people complain about this behavior, like, oh, usually when I double click, this dimension value comes up. Yep. That's probably because this Instant 2D may be on or off. I like working with it, but I also like knowing it can toggle. I'll stretch that out. click the OK, and then we have a nice rebuild. So test it too. Like go back and test your assumptions very early. Can I make a change? I would save it before you do that because you can just reload versus Control Z, which is a lot of times a little bit easier. But I'm fine with that. And eventually, over time, I'll build the top tube, separate body completely, the bottom tube or the down tube, the one that goes down, better with the visual. This one I would build separately. This, and then once we have all of the main components, then you come through and start to refine what those transitions looks like. Same thing. It's just going to be using a series of extrudes, swept surfaces, boundary, and filled surface. And if you're not familiar with these ones, they're really powerful. You can play with them, and they're relatively easy to use once you play with them. Now, fast forward. That was, remember, 2017 is when I started playing around with using SolidWorks to do bike design. And then recently, I'm not an X-shape guy, and I should be because I love surfacing. But we have people on our team. Andy Barnes, who's like the best X-shape user in the world. I hope Andy's watching. And then Jordan's not too bad, and Gian's really good too. So I've been playing with like the new X-shape tools, and the reason I hadn't done it at this point was we didn't have good ways to merge multiple bodies, and you need that, and now they have it. And the other reason I want to plug this, because this is like the new workflow, is there's now you can just create sketches. And sorry, I'm like really bad at navigating in here, but essentially what I've done is you can create a sketch like this, and it's just a basic profile sketch, and then I extrude that out, and that's just an extrusion all the way out, and then that turns into a sub-D body. So just like we did in SolidWorks, where I create a series of extrusions, swept surfaces, I should say, or lofted surfaces or swept surfaces, whatever. What X-shape now allows you to do, same workflow, but then once it's created, I can push and pull it. And the other cool thing it does is once I get to this part, the hard part, in X-shape, I can just say connect that face to this face. And I would demo that, but I wasn't really planning on doing that. And I remember how I got here. Yeah, but I was this thing took me like 10 minutes to get to here. And this is a different bike.
Super cool.
So another way to play with it, if you have access to it, there we go. So starting to just kind of mess around with different workflows. But yeah, these transitions, like literally, this is just an extruded sketch. And then I just said, hey, combine those two. So I'll stop plugging those because this is SolidWorks Live Design.
SolidWorks product. A great one.
Sorry, I thought I'd go a little further, but it's complicated.
Yeah,
it's not a 1 hour design, as I hope you all appreciate.
Absolutely. That was super fun. Well, let's see. What else do we have? We've got a ton of stuff coming up. Thank you for coming on, Mike. That was super cool. And I learned a bunch of stuff just about bikes. So that was fun.
I got to talk about bikes for an hour. It's like, I usually get 5 minutes with my wife until she tells me to stop. Yeah.
Can't beat that.
So thanks for having me.
Absolutely. Let's see, coming up, since we're over, I guess we've got, we have a lot of stuff that's coming up. Actually, we've got Manufacturing Live that's coming up, and we'll be talking to Fernando Garcia. This one I'm really looking forward to. He's going to be talking a little bit about AI and how they combine that with robotics and how that plays a role in their industry facility. I'm looking forward to this. My friend and I have been passing AI manufacturing videos back and forth on Instagram lately, so I'm looking forward to seeing what's in there. Next week, same time as this, just to mention, that one is at a different time, just so you're aware that that's a 1 p.m. Episode. So if you're looking out for that one, that is at a slightly different time. But next week at this time, we have another episode coming up that I will also be hosting, which is going to be super fun. We've got Bogdan from Hacksmith that's coming on. We're going to be playing with lightsabers. So, I mean, that really can't miss. Really looking forward to that episode to see a couple of tips and tricks that he used in the process of building out that crazy cool model. We have another episode coming up of Live with 3D Experience World sort of preview. We've got some breakout presentations and their presenters, just kind of give you an idea of what's coming up for that. Really looking forward to World. We'll both be there for that. And speaking of World, their early bird registration for that does end today. So if you haven't gotten in on that already, go ahead and do that. That is it's like $300 off of the price. So if you haven't done that already, go ahead and do that. Today is the last day for that. So make sure you get on that, and hopefully we'll see all of you guys there. It's going to be a great time in February in Dallas. So I'm really looking forward to that event as well. So that's all we've got for today. We'll wrap it up, and we'll see you guys in the next one.